Thanks, Gwen. I'm really happy to be here. It's great to be a part of this wonderful event that SOSV is putting together. I have an even more illustrious panel than myself who's going to be joining me to suss out some of the issues around carbon capture, sequestration, and utilization. I want to start by introducing this great panel. First, we have Josh Santos, who is an MIT-educated chemical engineer and the founder and co-founder and CEO of Noya. That company is reducing upfront capital costs and time required to perform direct air carbon capture by retrofitting industrial equipment like cooling towers to capture CO2. He previously worked scaling electric vehicle production at Tesla and at Harley-Davidson. We also have KOLSTER, who's the director of science at Lowercarbon. She leads the firm's direction, diligence, and support of companies that can remove, reduce, or mitigate impacts of atmospheric CO2. Dr. KOLSTER is a chemical engineer who's worked with various decarbonization technologies, affording her a deep understanding of energy systems and climate policy. And she helps Lowercarbon with its mission to unexpletive the world. Can we say unfuck, Ned? Anyone? I think I'm going to say it. I just did. Woo, look at me. Last but certainly not least, we have David Say. He's a graduate of Princeton University who previously managed the aquaculture seed fund Aquacopia. David now leads NovoNutrients, which transforms CO2 into alternative proteins for feed and food. Y'all, thanks so much for taking the time. It is a pleasure and a privilege to be with you today. So I think, CLEA, I want to start with you, and I'm going to start with a really big question that could take the entire length of our discussion time here, but hopefully you'll be able to handle it in a concise and clearer manner than I could. I'm wondering what role you see these kinds of technologies, carbon capture and utilization, play in climate mitigation versus sort of industrial decarbonization or the advancement of fossil-free energy generation. How important is it, and how much money should people be putting behind it?
Thanks, John. That's an awesome question. So the shortest answer to that is we need all of it. You can't do one without the other. But I'm going to go through some numbers that might help put this into a little bit of perspective. So ultimately, we need to remove on the order of trillions of tons of CO2 from the atmosphere. And that translates to the carbon removal business basically taking on the oil and gas industry. So I'm going to go into some of those numbers, but basically today we've emitted on the order of about a few trillion tons of CO2. We've increased our average surface temperature to about 1 degree C, and we're looking at this dire goal of limiting that temperature increase to 1.5. So the combination of the fact that we continue to put about 50 gigatons of CO2 in the atmosphere every year means that we have about 8 years roughly before we hit that limit. So all in all, we need to do everything to decarbonize as fast as possible. But unfortunately, even the way that we stand today, we're seeing the advent of wildfires, floods, hurricanes just become a way too frequent occurrence. And that is reflective of the fact that we have emitted that much CO2 and other greenhouse gases into the atmosphere. So whether we achieve net zero or not, we need to roll back the amount of CO2 that we've emitted. So one more set of numbers. I mentioned that the carbon removal generally needs to become on the order of the size of the oil and gas industry, $1 trillion market. So today we remove very little CO2 from the atmosphere. Voluntary markets have grown very fast, but that's about $1 billion industry. And when you think about that with respect to the petrochemicals industry, for example, and the fact that everything really stems from a carbon chain, why not leverage that and take the CO2 that we can remove or capture from industrial sources and put those into those very large markets? The petrochemicals industry is about a $500 billion annual industry. The global aviation fuel industry is another $200 billion. And we can make most of those things through new processes that we've developed, that we have great scientists, including the ones here, that have developed to take CO2 and make valuable products. So to conclude, we need it all, but we definitely need we definitely need to be thinking about large-scale carbon removal. And I'm excited to hear the perspective of the panelists that we have here today on that.
Yeah, and I think this is a great time to sort of get the take of the two entrepreneurs in the room on how they see this thing shaking out and the roles that they see in this process. So Josh, you sit at sort of one end of the spectrum, and I'd love for you to talk a little bit about exactly where Noya does sit in this process and whether you are more geared towards helping folks on the utilization side, so taking some of the existing carbon and turning it into other materials, or whether you can work with some of the folks that are looking at sequestration alone. And if you could give me your thoughts on sort of Noya's particular application, given the size of the kinds of systems that y'all are developing, I'd appreciate it.
Thanks, John, and appreciate the intro from CLEA as well. The work that we're doing at Noya is unique and different, I would say, from what a lot of other people in carbon capture, and specifically direct air capture, are running on. Our approach utilizes existing pieces of industrial equipment to capture CO2, and these existing pieces of equipment are spread out all across the United States. The cooling towers that we're retrofitting exist in the millions. There are 2 million of them that are all across the United States that we can go retrofit and turn into DAC machines wherever they stand. And so we are going to have the opportunity to build this massive distributed network of carbon vacuums that's essentially hoovering, if I can use that verb, carbon out of the atmosphere and putting it to work. That work can exist and will exist in many different forms. There may be some instances where it makes more sense for us to take that CO2 and provide it to people that are turning it into useful products, be it what we used to think of as petrochemicals that we need a new name for now, or whether it's something else entirely that we're just using to make a good or that people are going to use. That's one use case that our CO2 is going to be able to use, and we're going to be able to meet that need wherever it is, because our carbon vacuums are going to be likely within 10 to 20 miles of the point of consumption for each of these processes as they come up. And so we're going to be right where the people are, and we're going to be able to provide it to them very easily. We're also going to be able to provide CO2 to people that are doing sequestration alone. And boy, do we need a ton of that. Tons, I guess I should say. Yeah. If you look at the 2 million cooling towers that are across the CO2, across the US, and estimate how much CO2 those cooling towers can capture just using average amounts that we've gathered in our existence so far, we estimate that there is a total CO2 capture potential of 10 billion tons of CO2 from the atmosphere each year using just American infrastructure that already exists. That 10 billion tons is too much for one market to consume. It's too much for utilization market. And so we're going to do both. And we're going to do both wherever the people that are doing those things with the CO2 that we produce already exist. And so, John, I think the answer to your question is we're going to do everything, because we're going to be right next to where the people are, and we're going to do it big.
Well, you're not going to do everything, right? Because I think David's company is going to maybe take some of that CO2 from you or from other industrial facilities and use that CO2, right? So you're not actually sitting at the point of utilization. You're not going to be making plastics. You're not going to be making proteins. You're going to be capturing that CO2 and then pushing it off somewhere. David, do you see yourself as a potential customer for the CO2 that Noya is capturing, or are you directly on facilities yourself? Are you working on at the?
Yeah. So when we think about carbon dioxide, in a certain sense, we're a customer, which we might be to a company like Noya, where we would purchase CO2. And in other situations, we'll be a vendor of, for taking carbon, because we don't need pure CO2 to do our precision fermentation and create healthy alternative proteins and other products. And so we look forward to be able to play, in a certain sense, a little bit on the carbon capture side, but mostly on the utilization side.
And when you think about the sort of a capacity that you have, or your technologies or technologies like yours have, to absorb the CO2 that needs to be pulled out of the atmosphere. And you talk about this capacity that Josh was speaking to, of about 10 billion tons annually. Like, how much of that do you think a new sort of food system can absorb that's going to be utilizing this?
Yeah. So
is that a weird question?
No,
you could say, John, that's a really weird question.
No, it's not, it's not a weird question at all. It's something that I actually think about a lot. So one data point is that the amount of animal feed that is made every year is something above 1 billion tons each year. And so basically, you know, at a 2-to-1 ratio of CO2 mass to, you know, resulting protein product mass, you know, you could, in a certain sense, replacing that could be a 2 gigaton a year utilization. And there are certainly other applications for this hydrogen biosynthesis type biomanufacturing that we do. And just to be clear, we're interested in CO2 from both emitters, who are the current polluters essentially, and to help make a transition to a world where we're not only putting less CO2 up into the atmosphere every year, but also taking a lot down.
Now, CLEA, as an investor, when you look at some of these different technologies, and there are a lot of companies that are claiming sort of utilization opportunities, are all of these utilization methodologies created equally? By which I mean, like, you know, I don't want to single anybody out, but let's say you're making booze from captured CO2. Is that like a solution to the climate crisis that people should take seriously? And because, you know, anything that's sort of involved in utilizing CO2 and replacing the need for cultivation of land, additional agricultural cultivation, or whatever else. Is that viable and a valid argument, or is some of this stuff kind of, it's not greenwashing, but maybe it's greenwashing?
That's a great question, John. And to my earlier point, we need to essentially remove about 1 trillion tons of CO2 from the atmosphere by the end of the century. We need to get to something on the order of 10 billion tons of CO2 removed annually in the next couple of decades. So to the extent that you have markets that can incentivize and pay high prices for CO2 and incentivize the deployment of direct air capture and get more of that removed, I'm happy about that. But the point that you're making is around claiming whether or not you're actually reducing net CO2 emissions. And so there are two aspects of that. There's the fact that, for example, in the chemicals industry, you're extracting fossil fuels typically to conduct those processes, and it's very interesting. But 30% of the value of a barrel comes from only 4% of its actual mass, which is in that chemical piece. So to the extent that you can reduce the value of fossil fuels by finding ways to utilize CO2 and displacing those emissions that way, I'm very happy with that. Ultimately, we need to get trillion tons of CO2 sequestered underground, right? That is the ultimate solution. But in the meantime, if we can incentivize that with markets such as, you know, whether that's booze or you know, ideally things like what David is working on, for example, around protein, and plenty of others are, you know, at different levels of permanence. That's great in terms of incentivizing the market. If they're willing to pay high prices for CO2 and get the financing there to fund large scale direct air capture, have every single cooling tower in the United States be retrofitted with Noya's technology. That's what I'm most interested in.
And so what role do some of these big corporations that are responsible for the majority of these emissions have to play in the development, propagation, or commercialization of your own technologies? So do you see some of these traditional fossil fuel industry players as partners, as go-to-market partners, or or as obstacles to the development of your technology? And when do you reach out to them? David, well, Josh, I think this is a question for you, and then David, I have a question for you as well afterwards. So, Josh, if you wouldn't mind taking this one.
Yeah, it's a very interesting question to think about, because generally speaking, the people who are most responsible for the annual emissions that we see globally are also the people that have some of the biggest pieces of equipment available to retrofit. It's something that we think a lot about it at Noya, and fundamentally where we fall is that we need to be pulling as much CO2 out of the sky as possible, as quickly as possible. And if there is a path towards doing that with the existing big oil companies, we'd love to explore those. What we are going to always make sure of, though, is that if and when we were to partner with them, it is for that use alone. We want to make sure that since they have the largest pieces of equipment and the largest assets that are available, every single gram of CO2 we capture would be removed and permanently stored from the atmosphere. We do not want to do really anything else in partnership with those types of companies, because we think that it's a great use of the assets that they have, right? If those assets were previously put to use in things that resulted in tons of emissions that are now getting us into the mess that we're in, then we should use those to undo it, and we should use them to reverse it. We should use that infrastructure to help solve this problem. And so in those ways, we're open to it, and we'd love to explore those pathways and see what opportunities might lie there.
And David, a question for you, also about markets or different types of customers, but more sort of on domestic versus international markets and domestic versus international investors. So I understand, correct me if I'm wrong, but I thought you'd taken money from some international sources of capital. And I'm wondering if that means that you're going to be pursuing international markets versus domestic markets. And Josh, maybe this is a question for you too after, is like, how do you determine where the best go-to-market is for the technology that you're developing? And you know, what's in that calculus for you?
Right. So from our perspective, we really face two markets, right? Downstream from us, nutrition, and upstream from us, the availability of our input gases, not just CO2, but hydrogen, which is a larger fraction of our cost. And so basically, our production facilities should be located in places where there's a low energy cost, whether that energy is being used for direct air capture or for production of green hydrogen, or affects the opportunity cost of other ways to get hydrogen. In terms of, you know, the nutrition markets, where can alternative protein go into food, go into pet food, go into aquaculture feeds? You know, the United States consumes a relatively small minority of the world's food, although does it in a very resource intensive way. And, you know, has a good, we've been a leader in pets, but only have a low single digit percentage of aquaculture. And so it really points to a two-pronged approach where, you know, take advantage of how easy it is to do business and the kind of support and investor interest in the United States. But certainly for the nutrition markets, look to Asia, Africa, and the rest of the world as well. You know, one of the good things about the kind of products we make is that, you know, they're shelf stable for a couple years, can be shipped via sea freight, which is both inexpensive and more sustainable than other forms of transportation. But over time, we hope to have even more distributed production and shorter physical supply chains.
So I mean, it really is. It's a question of demand, right? So most of the demand that you're seeing in these foreign markets. Is there also a larger opportunity for carbon mitigation or offsets in those markets too that you're seeing that makes them potentially more attractive?
Yeah, I mean, for us, it really depends on how they're defined. You know, how the regulators, the lawmakers are defining what earns a carbon credit or what avoids a carbon penalty. And so, you know, the reference was made earlier to, the duration of sequestration. Ours is relatively short. Carbon comes into our system. Eventually, it's released by the digestive system of wherever the nutrition ends up, and so that may or may not qualify under certain regimes, right? In other places, it's clear that enhanced oil recovery, for the oil and gas industry is included, but biological carbon capture utilization may not be. But overall, it's certainly, I think the most important thing at this point is that those kinds of trends towards these economic pushes is creating a lot of interest in our technology. And we think that can be a virtuous circle where the more interest and activity we have, the more likely these things will be seen as a good place to do some carbon economy accruing of value.
Yeah. And Josh, I mean, you talked about the ability to capture 10 billion tons of CO2 in the U.S. and the sort of vast potential opportunities to slot your technologies onto industrial systems here in the States. But I would imagine that the global market also presents an equally large, if not larger, opportunity in places like China, India, huge industrialized countries as well. How do you go about sort of determining which market makes the most sense and where you can have the most impact? I almost wonder if, given the different sort of power mixes in some of these places, whether looking to China to deploy quickly first, would have an outsized impact from a mitigation perspective.
Yeah, I think that is something that we've absolutely considered, and you're right in that cooling towers are not an American-only piece of infrastructure. They're quite common. As it turns out, other people also need to cool things down. It's not just us. And so we recognize that there's tons of opportunity available, and we've been talking to at the early stages of talking to companies that exist all across the world, whether that's somewhere in Europe or different parts of China and India. We're talking to folks all over the place. I think fundamentally where it really comes down to is, where is that demand for the end-to-end solution going to be strong enough for us to be able to build and scale quickly? And that includes not just going out and finding the customers, but also going out and completing the implementation and actually getting the retrofits that we need to put into the ground. So right now we see a ton of immediate opportunity available for us here in the US, and there are some specific local markets that are hungrier than others. If you look at, as an example, some of the regulation that New York City has recently passed to put a cap on the emissions that different commercial buildings are allowed to emit. That has forced a lot of people to start looking for additional solutions, and we've had lots of great conversations just come out of that alone. Right. And there are many other cities across the country that are also looking at something like this. So there is enough strong, immediate, urgent need domestically for us to, at least for now, stay focused on the US. And we know that in the future, we will be in all of these other places as well. It just starts with doing the first thing first for us. And right now, the first thing is here domestically.
Right. How soon do you reach out to corporate partners, and how important is having enough internal capacity in place for manufacturing of components or thinking about your internal supply chain before you start reaching out to more than one pilot partner or several partners on deals?
It is paramount. We have been incredibly fortunate to have lots of huge corporate players come knocking on our door asking for our solution, potential pilot opportunities, and what it might look like to implement the work that we're doing on site with them and at their factories. We're not able to do. We have more people that are coming to us than we can actually meet. And so for us right now, the biggest challenge is being able to grow our own internal capacity to meet those customers where where they're at, quite literally where they're at on their sites with their equipment. And so I think that it is incredibly paramount for all types of companies like ours generally that are doing hardware, hard tech, science focused work to think about that operations aspect of it, think about that internal development aspect of it from the very beginning, because that we know was one of the big learnings from the early clean tech days, was to focus on that and don't leave it alone, because building tech's not enough. And so that's something that we think a lot about, and I think it's incredibly important for companies like ours to get right.
David, how have you approached the scaling issue? Because one of the problems from the previous generation of clean tech companies, especially working with biology, was scaling that biology, right? And getting to sort of production scales without running into incredible cost overruns and some of the other problems that are associated when you're cultivating a product using biology that you know sort of gets tricky at scale.
Yeah. So one of the things to do is to narrow your focus of innovation and try to stand on the shoulders of giants as much as you can. So we're building a biomanufacturing platform, but it's built in many ways on pre-existing technology platforms, on the existing sophisticated fermentation industry, on the way that chemical and process engineering has really matured as we come into the 21st century, from the synthetic biology work that various solutions and tool providers are making. And so if we stick to the areas where we're really doing something novel, then a lot of the scaling issues are taken care of, because these are problems that others have solved before, and somebody is selling that solution that could be part of ours. So that's really how I think about it. And the other thing is patient capital, right? You need to find investors who are willing to support a multi-stage scale-up process as you go from a laboratory benchtop to the floor scale, to a pilot out in the field, to something that's 20 times larger than that, what's often called the demonstration scale, and then to small commercial scale, large commercial scale, very large. And so that takes years, and so you have to have employees who are patient enough, investors who are patient enough.
We are almost out of time, and I want to leave with one final question for you very quickly. It's been a hard start to the month of October for climate, given the energy crisis and the ways in which that might put pressure on people to backslide into a fossilized economy, refossilization instead of defossilization. But I'd like to get one fact from you that gives y'all hope about a climate positive future, because that's what we're aiming towards. So if there's one piece of news over the past month or the past year that really makes you hopeful about what's ahead in our climate journey, cheers, Jason Jacobs. Let me know what that might look like. CLEA, let's start with you.
Yeah, sure. I'm gonna say multiple things. I'm sorry, but I'm super excited about the fact that you have gene sequencing that's cheaper than ever. People are working on new bacteria to make those chemical products that we need, and all of those are contributing to the fact that we can actually get better and cheaper products through the pathway of CO2, and that's what's really important. I mean, ultimately, we need to that those costs need to go down. And then the other thing is just I'm super excited about the fact that you have companies like Microsoft, Stripe, and Shopify that are paying real money to actually remove CO2 from the atmosphere, and I think they're setting a trend. And I get the sense that many companies are going to follow pretty soon.
David, how about you?
I'm a rule follower in some cases. I'll stick to one. So earlier this year, the U.S. Department of Energy declared that the country was going to achieve $1 per kilo green hydrogen production by 2031, which would have remarkable effects not just on our business, but on really making this new form of chemical energy storage, this very potentially carbon effective method a reality and quite widespread. So that's the best news I've heard recently.
And Josh, take us home.
The biggest thing that excites me and gives me hope, aside from everything that CLEA and David just touched on, is the fact that now more than ever, there's I'm trying to think of a word strong enough, a surge of interest of people that previously had jobs outside of climate that are looking at moving into climate. It is to the point where there are now whole companies that are starting to connect people that were not in climate to companies that are working on climate to help people work on climate. And I think that more than anything gives me hope because, yeah, we need all of the federal mandates like the offshore wind announcement that happened not too long ago and the green hydrogen announcement, like all of these things federally do need to happen. None of that matters if we don't have people to do it. Right. And so I think that the most exciting thing for me is that every day there are more and more people that I'm seeing through various communities, virtual, real, whatever, that are looking, that are focused around and highlighting people that are joining the climate career movement. Right. It's something that is probably the most important thing that any of us can do to help make this issue be solved faster. Yeah. And it's the one thing that continues to give me hope through this.
And those are people, I should say, like those in the audience who are hopefully listening into this very conversation, and people like our gracious hosts at SOS Ventures who are investing in some of these companies, and Lowercarbon, and My Climate Journey, and Footprint Coalition, and all of the entrepreneurs that are working on solving these problems as well. We're all part of this community, and I think we're all pushing forward. This has been a really great conversation. Thanks to all of my panelists for participating. And thanks, Gwen, for giving us the opportunity. And back to you.